Check.
In May 2017, a pilot flying over Nevada spotted an object that did not fit any known aircraft profile. The video, filmed through the cockpit window, shows a metallic, disc-shaped object hovering at a distance against a backdrop of dry desert hills. It appears to rotate slowly, catching the sunlight on its smooth surface, then drift without any visible means of propulsion. The pilot, trained to recognize all types of civilian and military craft, called out to a colleague in the cabin, both of them clearly surprised by what they saw. As the plane drew closer, the object glided horizontally, maintaining a steady altitude that matched the plane's flight path. There was no sound, no exhaust trail, and no wings or tail fins. The shape remained consistent throughout the sighting, suggesting a solid, symmetrical design rather than a cluster of balloons or debris. In the video, the pilot tries to adjust the camera angle to get a clearer view, but the object moves just enough to stay at the edge of the frame. After a minute or so, the UFO accelerated away at a speed that outpaced the pilot's efforts to follow. It vanished over a ridge, leaving no sign of conventional propulsion or after effects in the sky. The pilot's report later described how the object's motion did not match any weather balloon, drone, or experimental aircraft he had ever encountered. The local air traffic control had no records of any traffic in that corridor at the time. So the question is, do aliens exist? Do they visit our planet? In 2017, an observatory in Hawaii detected something that would change the way astronomers think about our place in the galaxy.
I was in charge of coordinating the observing to characterize the object. The object was discovered, and at that point there were images taken that showed an object moving rapidly with respect to the stars.
As they scanned the heavens for near-Earth objects, they spotted a small, fast-moving point of light that did not behave like any asteroid or comet they had seen before. It was moving too quickly and along a trajectory that suggested it had not originated in our solar system. Astronomers confirmed that this was the first known interstellar object to enter our solar system, and they named it Oumuamua. It was initially classified as an asteroid, but its unusual characteristics left researchers puzzled. They observed that it lacked the typical visible coma or tail associated with comets, yet its motion through space was influenced by something other than gravity alone.
An asteroid was discovered coming into our solar system. Let that sink in. An asteroid was discovered coming into our solar system. From where, we don't know. It just came from outside our solar system, meaning it's from a different star system somewhere else. That's historic, that we've actually seen it. We now know objects can travel from one star system to another.
Various theories emerged to explain its behavior. Some scientists proposed that it could be made of exotic materials like hydrogen ice or nitrogen ice, which would sublimate in the outer solar system without producing the dust and gas halo that we associate with comets. Others suggested that solar radiation pressure could explain its acceleration, implying an extremely thin, sheet-like structure. A small group of researchers, led by astrophysicist Avi Loeb, went further, proposing that Oumuamua might be an artificial object, perhaps a probe sent by an extraterrestrial civilization to observe the planets of other star systems. At the time of its discovery, Oumuamua was already on its way out of the solar system. It was first seen when it was about 33 million kilometers from Earth, roughly one-third of the distance to the Sun. By the time astronomers realized what they were looking at, it was too late to mount a mission to intercept it. They had to rely on the data collected as it passed by. Measurements of its light curve, the way its brightness changed over time, revealed a stretch of nearly 10-to-1 in its maximum to minimum luminosity. Such a variation indicated an elongated shape, perhaps 10 times longer than it was wide. reminiscent of a cigar or pancake rather than a simple rock.
It had a very funny shape. It's shaped like a cigar. It's maybe 5 or 10 times as long as it is across. No asteroid that we know of looks like a cigar. Inevitably, there were people who said, well, are you sure it's a rock? Maybe there's somebody inside this thing. Maybe they've come to visit.
Spectral analysis failed to pinpoint its composition, as its surface did not show the clear signatures of silicates, metals, or ices that would allow a confident classification. Observations from different telescopes around the world and in orbit provided conflicting hints, but none could conclusively identify what Oumuamua was made of or why it danced through space in the manner it did. These mysteries are compounded by the fact that an interstellar object moving through the vast emptiness of space should travel at high speed relative to the Sun, inherited from its original system's orbital motion combined with the random motions of stars in the Milky Way. Yet, when astronomers worked out Oumuamua's trajectory, they found something odd. Before it approached our Sun, its motion relative to the solar system's barycenter seemed unusually slow, as though it had been hovering before deciding to enter. After its closest approach to the Sun, its path deviated from the purely gravitational parabolic arc expected for a passive rock. It appeared to accelerate slightly away from the Sun, more than gravity alone would allow. This pattern of acceleration slowing as it moved away from the Sun matches the behavior of comets, where sublimation of volatile materials provides a tiny thrust. Still, observers saw no comet-like tail or coma around Oumuamua, even though sensitive instruments were looking directly at it. If outgassing was the cause of the extra push, it was in a form invisible to our detectors, perhaps jets of molecular hydrogen or nitrogen, each hypothesized in turn but never confirmed. In light of these oddities, some researchers began to entertain the possibility that Oumuamua was not a natural object at all, but a spacecraft of some kind, possibly equipped with a solar sail. A sail would harness the pressure of sunlight to produce acceleration, and the thin, sheet-like structure required for that could explain why outgassing was not detected. No gas would need to escape if radiation pressure alone were at work. If so, Oumuamua could be the first tangible evidence of extraterrestrial technology reaching our neighborhood. To many, the idea sounded like science fiction, but Avi Loeb argued that as long as the object's characteristics were unlike any known natural body, an artificial origin had to be considered seriously. In his view, reasoning that it must be a natural object simply because it is unique would be circular logic. Instead, each anomaly should be treated as a clue and evaluated on its merits. Because Oumuamua departed the solar system too quickly for any spacecraft to chase it, Loeb and his colleagues turned their attention to preventing a similar object from escaping observation in the future. They launched what they called the Galileo project, named in honor of the astronomer who first turned a telescope toward the heavens to challenge conventional wisdom. The aim of the project is to build dedicated telescopes and instrument arrays to scan the skies for fast-moving objects entering and leaving our solar system. By catching them earlier, researchers hope to collect higher-resolution images and spectra while the visitor remains in range. They have proposed outfitting telescopes like the Vera C. Rubin Observatory in Chile with specialized cameras and algorithms designed to spot interstellar objects in real time, distinguishing them from the far more numerous asteroids and comets bound to the Sun. The Galileo team also envisions using artificial intelligence to sift through terabytes of data from existing sky surveys, looking for patterns that human analysts might miss. If a future visitor reveals itself, the project hopes to marshal ground-based telescopes around the world, and even small satellites in low Earth orbit to study it intensively before it slips away. While the Galileo project focuses on objects intersecting our solar system, another line of thought considers whether alien observers might already be watching Earth. Astronomers have worked out the so-called transit zones, regions of space from which an extraterrestrial civilization could see our planet cross in front of the Sun. When Earth passes between a distant observer and our star, it blocks a tiny fraction of the Sun's light, causing a slight dip in brightness that, with precise enough measurements, reveals the presence of a planet. This method, used by astronomers on Earth to find thousands of exoplanets, works the same in reverse. Researchers have calculated that over the past 5,000 years, there have been more than 1,700 systems where paper-thin lines of sight align just right for Earth to transit the Sun. In 46 of those star systems, planets orbit close enough to their stars to intercept our radio transmissions, which have been broadcast since the early 20th century, and now leak beyond our atmosphere in all directions. From some of these worlds, hypothetical observers could have noticed the telltale signals of human technology, from early radar pulses to television and radio broadcasts. Among those planets, 29 lie in what scientists call the habitable zone, where temperatures might allow liquid water to exist. Anyone living there with the right instruments might have already glimpsed evidence that our planet harbors life, and possibly intelligence. Certain star systems hold special interest. The TRAPPIST-1 system, for example, lies about 45 light-years away and hosts 7 Earth-sized planets. Astronomers have found that 4 of these planets' orbits align such that inhabitants on their surfaces, if they exist, would see our planet transit the Sun and might even detect our radio leak. But because the system is 45 light-years distant, any signal we sent when Oumuamua arrived would take decades to reach them, and their observations of our planet's transits would show events from over 4 decades earlier. Likewise, the planet Ross 128b, about 11 light-years away, may have had a clear view of Earth's transits for thousands of years, but about 900 years ago, motion in its system caused misalignment, closing the window on our transits. In the coming decades, the 2 planets circling Teegarden's star, at some 12.5 light-years distance, will come into alignment, providing an opportunity for their hypothetical inhabitants to spot Earth crossing the Sun in just 30 years. If they already possess radio technology, we might one day receive signals from them, though the earliest reply would not arrive until more than 25 years after we first transmit. All of this suggests that we are not the only eyes watching the cosmos. Some civilizations, if they exist, might have already discovered our world. As speculation runs rampant, it becomes tempting to imagine what form alien intelligence could take. Some might be curious explorers seeking knowledge. Others resource-hungry civilizations in search of materials to sustain a vast technological society. In the wildest scenarios, we imagine beings who have breached the speed of light barrier or engineered spacecraft that skitter through the void by bending the fabric of space-time. And as we indulge such conjectures, we cannot help but wonder if some observers are less friendly, perhaps even advanced, intelligent insectile creatures with motives we cannot fathom. With uncertainty mounting, governments have begun to take the possibility of real, unidentified aerial phenomena more seriously. In June 2021, the United States Congress issued a report on UAPs, or unidentified aerial phenomena, the preferred terminology over UFOs, which had become tainted by pop culture associations. The report cataloged 104 incidents recorded by military personnel since 2004 that remain unexplained. 21 of these involved objects displaying flight characteristics or velocities that exceed known technological capabilities or perform maneuvers inconsistent with conventional aerodynamics. One video shows a strange object moving against headwinds at high speed. Another record captures a UAP darting along an odd trajectory before vanishing from radar. In a third clip, two quicksilver shapes dive into the ocean and emerge in unison before shooting away. The report stopped short of declaring alien visitation. The evidence, while perplexing, remains too limited to confirm non-human origin. Most sightings occurred incidentally, often near military installations, by pilots and radar operators who were not looking for extraterrestrial visitors. If we had an all-sky, high-cadence surveillance network tuned to catch UAPs deliberately, how many more of these curious phenomena might we find? What if some of them are spacecraft from civilizations that have reached Earth undetected? We still do not know their objectives. They might simply be gathering intelligence, much like unmanned probes mapping planets before sending home data. They could be prospecting for materials, scanning for metals or water supplies, or they might be staging pre-invasion reconnaissance, measuring our defenses before a larger force arrives. Given our current detection capabilities, we would likely have no warning until it was already too late. To address this vulnerability, scientists and space agencies propose two complementary approaches. The Galileo project envisions a ground-based network of fast-response telescopes and spectrometers, coupled with real-time data processing, to catch interstellar objects like Oumuamua, or anomalous near-Earth objects, before they vanish. By comparing each object's trajectory to precise models of solar system dynamics, the system could flag visitors from beyond and allocate resources to study them in detail. Meanwhile, the European Space Agency plans a mission called Comet Interceptor, scheduled for launch in 2028. The idea is to park a set of 3 small spacecraft at the second Lagrange point, about 1.5 million kilometers from Earth, where gravitational forces balance and spacecraft can remain in position with minimal fuel. From there, the interceptors will wait for a suitable comet or other target to pass within range. Once a target is identified, the spacecraft will break formation and approach from different angles, providing a 3-dimensional view of the object's structure, composition, and activity. While the mission is designed primarily to study dynamically new comets arriving from the depths of the outer solar system, the same approach could work for an unknown visitor. If the interceptors detected an object with non-natural acceleration or an unusual light signature, they could gather critical data long before it reached Earth orbit. Despite these promising plans, neither Galileo nor Comet Interceptor is fully operational yet. In the meantime, our best tools for finding interstellar wanderers remain the large survey telescopes like Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona. Pan-STARRS can detect about 99% of asteroids larger than 300 meters, while Catalina finds 90% of objects larger than 40 meters. These programs focus on cataloging potentially hazardous asteroids, fragments of the solar system that could collide with Earth. But any interstellar object passing through could slip through their nets if it is small, dark, or moving in an unexpected direction. A solar sail-driven probe, for example, might present a minimal cross-section to radar and optical surveys, evading detection until it is nearly upon us. Until we deploy a dedicated alert system, we remain blind to the smaller visitors, the probes or trackers that a hypothetical civilization might send to study Earth at close range. Such devices could be no bigger than a coffee table, seasoned to blend into the clutter of near-Earth space. They might perch in geosynchronous orbit, quietly listening to our broadcasts, or slip in and out of lower orbits under the cover of darkness. We would not notice them unless we looked specifically for objects that move differently from the debris of our own making. By building an alert system that flags any object exhibiting non-Keplerian motion, movement that does not follow the gravitational rules of ellipses and hyperbolas, we could begin to sift the natural from the potentially artificial. Having such an alert system would raise profound questions about how we treat visitors from other worlds. Suppose we detect a craft on approach, exhibiting powered flight and technology far beyond our own. Do we hail it as a moment of wonder and discovery? Or do we aim our defenses? Should we establish a space customs office to inspect incoming spacecraft, vet their passengers, and enforce quarantine protocols against unknown pathogens or technologies? If an alien craft carries a virus or nanoscopic agent engineered to target human biology, a customs inspection might be our only protection. We would need a list of prohibited items, organic materials, advanced computing systems, unknown chemicals, to prevent a catastrophic breach. At the same time, we might miss a historic opportunity to learn from another civilization. The idea of deporting visitors to a holding orbit, detaining them until a diplomatic solution is reached, feels almost medieval. Yet it might be the only path to safeguard our species. All of this uncertainty prompts a final question. Are we ready to handle proof of extraterrestrial technology? We have built sensitive telescopes, launched interplanetary probes, and set up space agencies to explore our solar system. Yet the frameworks for encountering alien intelligence remain untested. Our laws do not cover artifacts of non-Earth origin. Our communication systems are not designed to translate unknown languages or code structures. Our psychology has never faced the knowledge that we are not alone. If tomorrow we picked up a radio signal from Teegarden's star, deciphered as a greeting, how would we respond? If an interstellar probe drifted into Earth orbit, broadcasting images of distant worlds, what would we learn about ourselves as we scrambled to interpret its mission? The story of Oumuamua reminds us how little we know. In a single weekend of observation, astronomers went from routine asteroid tracking to confronting the possibility of alien technology. They faced questions about physics, biology, technology, and philosophy all at once. As Oumuamua vanished back into interstellar space, leaving behind only a trail of data and debate, it left us with a challenge: to build the tools, the systems, and the mindset necessary to catch the next visitor before it escapes. Whether that visitor is a comet made of ice, a fragment of a distant rock, or a sail-driven probe sent by another intelligence, we owe it to ourselves to look up, to pay attention, and to be ready. Only then can we turn the next question, "What is it?" into a new chapter in our understanding of life in the universe. So what do you believe? Do aliens exist or not? Tell us in the comments below, and subscribe to our channel for more content.